So hi, Matthias. Welcome back.
Hi, Adam. Thank you for inviting me.
So today we'll move away a little bit of Kumuluz EE and Java EE and focus more on API gateway.
Kumuluz EE is just one part of our digital platform. So the Kumuluz digital platform is more than just the microservice framework. The Kumuluz EE, the microservice framework, is the open source part, free to use and so on. But we have developed some other parts. One of them is Kumuluz API, which is an API management platform, which consists of an API gateway. It has a management part and what we call the API marketplace, which is sort of, let's say an advanced developer portal. And then we have some other parts of the Kumuluz platform. One is the integration part, where we focus on using CDC, change data capture integrations. And the other important part are the Kumuluz business APIs. The Kumuluz business APIs are the APIs that are used for setting up a digital platform, and we use these with clients who have decided to develop some digital services, so digital products, digital services, mobile apps, web applications, and so on. And basically what we focus on is the omni-channel architecture. So we have put a lot of effort in designing the whole stack, particularly the business APIs and everything beneath in a way that we can set up an omni-channel architecture where we can actually support all the different digital and also physical channels. For example, if we would have a retailer, for example, then this retailer can then use these APIs, which are implemented as microservices, of course. They can use them for all the channels. So should it be a web shop or physical store or whatever channel they implement.
Okay. And there is, of course, Kumuluz crowd sensing as well.
There's a Kumuluz crowd sensing. This is another product that is currently in the development. We are basically finishing the development, and the crowd sensing platform takes over all the responsibilities of customer engagement. So basically, we can collect all this data regarding what customer wants, what products does he look on the web page, on the mobile application, which stores has he visited. Actually, it's a product which has quite several use cases. We are currently implementing a use case with mobile, so electrical vehicles charging.
Okay.
And this project is interesting because we have used our Kumuluz crowd sensing platform in a way where we actually not only provide the location of the charging stations and information whether the charging station is available and so on, we also estimate the battery charge, so state of charge of the batteries in the electrical vehicles, but not in a way where we would need to interface with each separate car, but we do this based on our crowd sensing platform, which enables through the mobile app that we monitor the driving. So basically that we monitor whether somebody has driven a car and what destination he has driven and what speed and so on. And based on that, we can calculate, so approximate the state of charge. And based on this information, actually, we can estimate when a user will want to charge the car.
This is actually great. It sounds also very complex to build, actually.
Well, it's quite complex, yeah. It's still a project in progress, yeah. Well, it is complex, but it's not that complex, to be honest. We have developed for a few years the technology for using the inertial sensors in the mobile devices so that we can capture the inertial sensors movement. And based on this, we can calculate various things. So one of them is to know whether somebody is driving a car, what speed he is driving, and then also if we add the location, we can see whether this is, for example, driving in the city or whether it's a highway and so on. And combining all those data can give us those results, which are which turn out, because basically the first attempt was to interface with various cars and to get all this data, so the state of charge of the battery and all those data from the car itself. But it turned out that this is very, very complex and that the vendors don't allow you to interface with different vehicles. And this can then be quite a problem if you, for example, if you don't know what the state of charge is and so on and how to collect those data.
Is it like a research project or one for your clients?
Well, this is an innovation project. It is partly funded by the structural funds, so it's called the Edison project. But it's really interesting. Yeah, there are several partners which plan to use this as their operating production system. This is somehow similar to those Horizon 2020 research projects, which are funded for the first research part, but then to develop the product that it's market ready, you need to put some additional effort into it. Yeah.
Okay, and it's also great because you have the data, so you can run some experiments with machine learning or whatever, right?
Right, and we actually use machine learning for estimating the state of charge based on the distance traveled and the pattern, how the user is driving the car, and so on. And behind this is our microservices. So what we use is the Kumuluz EE framework. It's our API management system. Well, the whole system is set up on the open source projects, and the backend is Java based. This is maybe an interesting information.
Yeah, this is what I wanted to ask you. Not that talking for 1 hour and turns out this is a Visual Basic or something,
No. Yeah,
just kidding.
Yeah.
Okay. And yeah, a link would be great to show notes. What's the project called? Edison.
Edison, yeah.
Okay.
Yeah.
And the entire backend is Java and Kumuluz, then of course also MicroProfile, right?
The complete backend is Java, MicroProfile, yeah, that's right. Kumuluz EE, yeah. And everything is built in a cloud-native way. This is probably important. So all those microservices, stateless, all those cloud-native patterns. This is one of the projects where we really worked hard to introduce all the different patterns. So, for example, we use a central configuration. So this actually, I don't know if we already talked about this, but in the Kumuluz EE framework, we have gone a little bit further with the configuration framework. So not only configuration files and environment variables, but we also support ECTD or console as central configuration service, where microservices can store the configuration. So basically centrally, yeah. We are using a service discovery functionality. We implement all the fault tolerance patterns. Those fault tolerance patterns are also part of the MicroProfile. The service discovery, however, is not. Yeah. So basically, service discovery allows us to relate to different microservices based on their logical names, not on the URL locations, which turns out to be quite good, because you can do various things. You can do client-side load balancing. You can do client-side so traffic proxying. So instead of having a central API gateway, you can collect the information about the traffic between the microservices from each client, where you implement a small proxy on the client side, and then this proxy not only does the client-side load balancing, but also collect some information regarding the traffic of the microservice, sort of partial API gateway functionality.
Almost like a service mesh, sounds to me.
A little similar, but we didn't want to go into, we have some established products for service mesh such as Istio, and this is something, we put some effort to not to have the same functionalities.
You are actually a terrible conversation partner, because my plan was to talk about API gateway, and today you came out, with something more interesting, like machine learning, charging cars or something. So it's always, it's always if I try, to pick one topic, you come with 3 new topics which are more interesting. But
I'm sorry. Yeah.
But even more interesting, because so the last time we stopped talking about Kumuluz API, which is the API gateway. So I would like to re-invite you back, because there's no more time left, and just to talk about the API gateway part. And if there's time, we can cover other topics. But first, the API gateway, is it a standalone a proxy which runs on Kumuluz, which is Java-based, or what is it?
Well, actually, our Kumuluz API has quite a long way. We started the development some 7 or 8 years ago. And we started with the classical architecture, so having a standalone API gateway, and having a management platform, and then having an API marketplace platform where you can publish all the different APIs for different parties, for some third-party users who can get familiar with the APIs, start using it in a sandbox, and then apply for access, and then all the procedures. What we cover are also all the procedures how you can apply for using an API. So sometimes you need to sign a contract or something like that. However, in the last time, we have focused on developing a new generation of the API gateway. And here we have gone maybe a similar way as some other teams who have started to develop the Kubernetes native API gateways. However, we have separated some of the concerns. Some of the functionality is still in the API gateway, which is implemented as part of as an extension of the Kubernetes ingress controller. Some part of the functionality we are moving into the client, actually. So this is where these functionalities connect with service discovery, which I briefly mentioned before, and with some other functionalities. So let me just try to explain, to understand what I'm trying to say. So basically, an API gateway offers some functionalities such as security, so authentication, rate limiting, logging. It could be also audit logging and some other functionalities. Now, the traditional approach would be to have a central API gateway. Probably you would have a few of them, some for external traffic, some for internal traffic, and so on. This is the traditional setup. However, in the Kubernetes, this traditional architecture maybe doesn't fit as well as if you would implement the API gateway as a part of the ingress controller, which is well known. Yeah. However, we are trying to make another step because we know that in the service mesh, we get this sidecar concept, and the sidecar takes over some of the responsibilities of service-to-service communication. You can, for example, define some fault-tolerant patterns such as retries or fallbacks and so on. The other part are the proxies through which the communication between the services is managed, such as Envoy proxy or something like that. However, we were thinking, what if we would put some of this functionality into the client? So what we are currently trying to do and experimenting with is extending so for example, if you take a REST client and the proxy that the REST client creates for calling external APIs, what if so we are extending this proxy, and this proxy collects and manages the traffic to the APIs from the client itself and then collects the data centrally. This is one part, and it simplifies the deployment topology. It considerably simplifies the deployment topology because you don't need to have a central API gateway anymore. And it also fits better into the Kubernetes environment because, if you have the communication within the pods or external communication, you can handle the routes better. On the other hand, it also provides, it provides easier implementation of some concepts that we are also working very hard on them. And this is how to integrate the API gateway with, particularly with fault tolerance. So, for example, if we have circuit breakers, or if we have fallbacks and retries and so on, the API gateway should be aware of them. For example, if a circuit breaker kicks in, then it is good that the API gateway knows that the traffic to a certain instance of the APIs of the microservice doesn't work anymore, and so on. And I could say the same for all the other fault tolerance patterns. And now the challenge here is how to integrate all those mechanisms. So that, for example, if the API gateway is aware of horizontal pod autoscaler in the Kubernetes and knows that the service is scaling, and then if there is a circuit breaker which kicks in for a certain instance, that the API gateway knows this from the start, and that all this data is interconnected on one hand. On the other hand, that you don't introduce too much overhead with the configuration, with everything else. And what I mean with configuration is that you don't, if you have to configure each and every microservice, which API gateway will be used and so on. And what we are doing here is trying to make this configuration as simple as possible. And if you have worked with Istio or some other service mesh, you probably know what I'm trying to say. Because if you have several microservices or APIs in the architecture, the configuration becomes quite complex.
Yeah, and I'm also using API gateways a lot for different reasons. So this is what I wanted to talk with you. What's your opinion? Because I'm using this on Azure and a bit more on AWS right now for different reasons. And how this feels like, the API gateways on AWS is just there, is serverless, so it's distributed. So it's not like you have to install. It's like a fully managed AWS service. But if you use it, it feels like it is a small wrapper around your service. So it feels decentralized. So actually with one line Java code, you can install the gateway. And now is the interesting part why we use the gateway. And so the most common use case is to have OpenID Connect integration with external resource. This is the job of the gateway. Usually it's way easier because the authentication happens outside. Then SSL, of course, certificates. Also, this is a classic one. And then some more interesting cases. So in one case, we'll use the API gateway to limit the IP ranges from where the client is able to access this. This is one use case current. And the other one is rate limiting. And this comes more and more, that we are, per client, there's only 5 calls allowed per day. So, and this is the first use case I saw. So I would say in the recent years, I got lots of requests about API gateways, and I asked them why you would like to know it. And there was no answer, right? So it's like API gateways were fashionable, but no one knew why. So this was this. For health checks and routing, it usually happens in my projects either on DNS level. This is one earlier because you can have DNS policies, or one deeper on the load balancer level. But I'm using less Kubernetes and more like ready-to-use services. But interestingly, on AWS and Azure is a similar architecture. And this is why I was interested what the killer use cases are. And what I also, the problem with fallbacks and retries, so we had the conversations recently in projects. So I tend to do this still on the inside the microservice. And the reason is because you have more insight into the application state. So what I can do, I can say, in case the external service is not available, and I tried already 3 times, and the state of the domain object is this and this, and the database is in this state, I will do it or not. And if you do it from the outside, the API gateway or the proxy, this is just a proxy, they only see the traffic. They have no insight into your application state. So, and therefore, what you could do, but the others cannot, because you are providing all the products, you could actually ask your microservices, for instance, MicroProfile metrics, via gauge or let's say counter, and ask them, or be more specific, just expose additional metric API, and ask the microservice, should I reroute the traffic now or not? You know what I mean? So your API proxy could get additional insight by calling your microservice over, I would say, not existing yet standard, and ask, should I do it or not? So like extending the fault tolerance from MicroProfile. So the fault tolerance in MicroProfile, we just suggest you should retry, and the retry happens on the API gateway level. So this is what is lacking, because I saw all the attempts to expose everything to API gateway or service mesh. For me, it is very. My question then is why we didn't did this 20 years ago, because the Apache web server was always in front of WebLogic or JBoss or Glassfish. We could implement retry on everything on Apache level, but it was impossible because they had no idea what's going on internally. So why 20 years later we renamed the Apache to Istio, and now it's possible. It is still not possible. And all the conversations with project, I saw that it was a nice try, but I never saw it working because, and then of course you have split configuration problem. You have some retries on the application level, on some retries on the service mesh level, which are a mess to to test actually.
Yeah, that's where I fully agree with you. Actually, you just gave me a very good idea, and actually, what we are working on is not so different from what you are saying. It's just that you have added another layer on it. So having a standard protocol where an API gateway or whatever layer you have over your microservices would be notified about the fault tolerance mechanisms that kick in on the microservice level or in service mesh, whatever. This would really make a difference.
Yeah, and you could extend the microprofile, no? Because you are already...
That's right. That's right, yeah.
Mm-hmm. Because this is really lacking and missing, and this would improve the situation a lot, or make, the service meshes and API gateways a little bit smarter.
Yeah, and this is actually what we are currently working on, because what we have figured out through our experience on the project is that the API gateway has to have some knowledge about what's happening on the fault tolerance layer.
Exactly.
So if you do a retry, the API gateway should know that this is a retry, not just another call. If it's a fallback, the API gateway should also know that this is a fallback for for this initial call which didn't succeed, not that it treats it like just another call and doesn't have any correlation between them and so on.
Yeah.
And basically, extending the microprofile and defining a protocol, how this communication could work, that would be, I think, a major step forward. Definitely. Definitely.
And is your API gateway implemented in Java or with something native?
In Java, yeah.
Yeah, this is actually great because we could have, the first microprofile native or microprofile aware API gateway. Because
of course.
Because the other ones, this is like, for me, a little bit boring, I would say. They are just, monitoring the traffic and okay. I mean, this is like, proxy server, basically what we had all the time. But if you say, okay, now we focus on Java, then we can do more because you already know, microprofile. Then you can support Kumuluz out of the box, but also you could support Quarkus, Helidon, Payara, Whitefly, OpenLiberty, and all the other projects, which is a huge market. And you are actually an open source project, so this could be an interesting way to collaborate with the others. But maybe some there are enterprise projects would pay for the services just to get the patches right and everything. So now you would be in great time. So if you extend above Kumuluz.
Yeah, you're right. Yeah, because well, there is more. I think also the health check status. Currently it's like that. For example, Kubernetes does the health check, so this liveness and readiness probes. But once your service is down, there are other components in the system. For example, the API gateway should be aware of them. That the service is down. If you are using a service discovery, then the service discovery should also get this information. And currently, there is no integration between those building blocks, or how should I say? And having such a protocol would really allow all these different parts of the microservice architecture to integrate, which would make sense, which would make it easier to implement some scenarios, because these are the scenarios related to the resilience and reliability, but there are other scenarios. For example, what we are also working hard on is how to support the canary release process in the microservice and API architecture. Have you had some experience with that?
The canary releases or AB deployments, this is where you are shifting the traffic regarding to this. This is usually the job of the load balancer. So in your case, you don't have the load balancer. So I'm talking about clouds again. So
right.
And what usually happens, I do, for instance, ECS Fargate. This is like the classic one, or AWS Lambda. So what you would do is, there are different ways to tackle this, but so there are Docker container tasks, and the Docker container tasks are part of a service, and the service says, okay, we need 4 CPUs and stuff like that, and the tasks are versioned. And this is a part of a cluster, and now for the cluster there is a load balancer. And what you can do, you can have at deployment time, so if you deploy the service, you can choose different strategies. And one of them is canary or AB strategy. And or the default, if you do nothing, what will happen is you deploy a new Docker container, and if the Docker container is healthy, it will get the traffic, and the other one will just disappear after a while. But you can say, okay, 10% of the traffic gets the new version, and the remaining is the 90% is the other version. And this is the job usually of the load balancer, because it switches the traffic then to the next one. But this happens behind the API gateway in the cloud. So the API gateway is just is like the I would say like servlet proxy, more or less. Whatever you can do in the servlet filter, or in an aspect like Yeah, the classic one is authentication, authorization, auditing, and multi-versioning. So version-dependent routing, different stages, prod, dev, and test, and this happens on the API gateway. And the load balancing on routing happens one later, usually. Of course, you could combine this because you could say, there is a new version of the API gateway, but API gateway is more like if it is about keeping the URI stable. It's not about switching between versions, I would say. So the API gateway is more like if I have version number 1, route the traffic to this service, and this service could be canary release or not. So I would say the API gateway is similar to the super load balancer, which could even switch the traffic between clusters.
Well, there are several aspects, yeah. And what you described, definitely, this is the current architecture. But what bothers me is that this architecture is quite complex. This is one thing, yeah. So why do you need an API gateway and then a load balancer? And then if you have a Kubernetes, you get this, for example, if you expose it as a service, you have another load balancer then in the Kubernetes cluster and so on. This is one aspect. The other aspect, if I go back to the canary release, for example, if you deploy a new version and route some part of the traffic, some 10% of the traffic to the new version, and then some exceptions start to emerge, and then probably you will have a situation where a circuit breaker kicks in. Mm-hmm. Now, how would the load balancer or the API gateway, and the API gateway doesn't matter, how would they know immediately that the circuit breaker for the new version has kicked on and that they shouldn't route the traffic there anymore, and so on? So these are all the integrations that I think are required and are currently, difficult to implement, even if you are using the stack, the one stack, so a single vendor stack, or how to say, it's difficult to implement. If you would like to combine some components from different stacks, it's
only because what I described to you right now is Java agnostic. So this could be any container workload. So if you say we can do Java and we focus on MicroProfile, so we can do more, a lot
That's
more.
Right.
So you just ask me, what we are doing on AWS or Azure. So if you just focus on Java, I would even ignore Kubernetes, because if you think about JBoss back then, so what they had were smart proxies. And what the EJBs did in smart proxies, they had so-called cluster view. So they every few seconds they pulled the state of the cluster, and they knew where to route the traffic. And you had to say, is it an idempotent service or not? If the service was idempotent, the smart proxy automatically did retrace for you. So this was like the classic architecture for 15 years and now almost forgotten. But now you can do something again, exactly what they did before, over more standard protocols, no more over RMI rather than REST. And if you know that it's MicroProfile, so you can skip everything altogether, what I told you right now, because we can provide more specific and more usable solution, right? So it's no more, so we can skip all the generic part. But Kubernetes doesn't matter. So it is like if you say, okay, we are in Java now, we can do a lot more. And the smart stub from smart proxy from Whitefly could be a smart MicroProfile REST proxy, actually.
Right. Yeah, certainly. And there are then some other aspects. For example, probably where our views differ a little bit, and that's probably also because of the types of the projects that we are working on. For example, in the most projects, what we are trying to achieve is to create an architecture which is cloud vendor agnostic. So we don't use in many projects so the AWS or Azure API gateway, because in most cases we have a requirement that the project can be deployed on whatever cloud without any using some specific infrastructure of the cloud provider. And this brings us then to another situation where you don't want to use those services provided by the cloud vendor, but you want to use some built-in services. And if you consider this requirement, then it probably becomes even more obvious why I was talking about simplifying the architecture, because in such scenarios you want to have a controllable number of layers or infrastructure components that you would like to deploy.
Mm-hmm. But let's talk about portability, because this is also my thing. And so Kubernetes, there are projects which would like to go to the cloud. So, okay, fine. Why you would like to do it? Some projects have true reasons, like, disaster recovery, multiple data centers availability and stuff like that. Others have security reasons. Everything has to be encrypted, and in the clouds it's easier than on premise, surprisingly. So I would say clouds are more security, most data centers. This is truth. And the others just management decided, to go to the cloud, and no one knows why. So, but if you run on premise, I would say Kubernetes is a must. Because I would say something like Kubernetes, OpenShift or Rancher or is just great. I would say on premise, there is no. Okay, I'm in some project where small enough that we just run Docker behind Nginx, but this works perfectly. This is also a highly available project, but this is only one project inside a company, right? But if you get more containers, you need something which starts and stops the containers. And starting and stopping is not a problem. The problem are the ports. It manages the network, I would say. This is the huge part of Kubernetes. And if you go to the cloud, now, what many projects are thinking about to moving their Kubernetes stack to the cloud. And this is not the right choice. This is my opinion. So, but this is you have to do it to explain it to managers. Why not? Because Kubernetes is fairly new, and all the cloud providers, they already had the Docker management solutions, and the Docker management solution from AWS or from Azure is actually way simpler than Kubernetes. So, to have something on the cloud which starts and stops Docker containers in both clouds, maybe I need 40 lines of JSON, and I'm done. So if I would like to go just to AWS without Kubernetes, it is going to be cheaper, easier, everything, and to Azure the same. So this is the first. It is not worth to just run our generic MicroProfile applications on Kubernetes to be portable, because I am able to port faster an AWS Fargate application to ACI or Azure App Container Service or whatever it's called on Azure than from Kubernetes to Kubernetes. The next problem is in the cloud. So Kubernetes has everything self-contained. So it has own user management, or security management. If you move Kubernetes to AWS, you have to do it twice, actually. So you have, the IAM users on AWS and the Kubernetes users. And in a project, if you do it in a project, I already saw in the code reviews problems where developers weren't able to do that. So they run the Kubernetes on AWS with their own hard-coded credentials to get, access to the cloud. So it could even happen that the Kubernetes on AWS or Azure is less secure than the native service because it is not configured correctly. And the last thing is, it is way more expensive. So Kubernetes on cloud is way more expensive because you have to pay for the control plane all the time. And if you do the math, so I was in lots of projects where we moved out from Kubernetes to just Docker because there was no added value of Kubernetes on larger cloud. So this is I would say if you would like to go to one cloud vendor, so I wouldn't use Kubernetes. As a product, in your case, if you say, okay, we have a project which has to run everywhere, this is a different story. But even then, I would even think about using some more native services because they are way easier and way nicer integrated to the cloud than Kubernetes. Because Kubernetes is more like I would run a virtual machine from on AWS and say now I'm a cloud native. This is like complete an own ecosystem inside an ecosystem on top of another ecosystem. So this is my observation of Kubernetes, and I have to say, in recent years, we migrated a lot of projects away from Kubernetes to cloud-native services, and they were cheaper. Another thing about proprietary stuff, maybe an interesting point, something is lacking, namely Kumuluz functions. What you could do, and then you need API gateway. It is fairly easy, and this is almost done. You could actually write a small Kumuluz service which listens to HTTP events and translates them to JAX-RS. And then you can integrate as a MicroProfile app, Kumuluz MicroProfile app, and all your services as functions. And now we are talking because with Java, you are outperforming Python and JavaScript. So you save actively money, and this is that simple. It looks like a MicroProfile application, Kumuluz application, and the thing to do for you is just to interpret HTTP events from the cloud. And this is actually already done for AWS. There is a proof of concept is called serverless containers. And they already have a Jersey solution. So your job would be just translate to whatever you're using and invoke your Kumuluz. But then we were in migration projects where we migrated Java EE app to an AWS Lambda function. And it costs, like pennies a month. So almost nothing. Mm-hmm. And so I would say if you not consider this, you are missing out a lot. So and the Kumuluz function is like a vacation tip for you. So actually do it. And this is like, of course, you are going to be a little bit depending on AWS API Gateway, or I think it's called Azure Event Bus on Azure. But the dependency in both cases is a one-liner. So I'm saying on AWS, I need an event bus and a passing function. By the way, in Java, this is my only dependency. And of course, I'm depending on AWS. But if I have the same line of code, on Azure, so I don't care about the effort. And then you could be integrated. And by the way, such an API, gateway, proxy, whatever, could be a Lambda or Azure function. And this is completely out of Kubernetes. And I do a lot of work here. And because in the cloud, what I see already coming is, cost-driven development. So everyone would like to have Kubernetes, but no one is aware of the costs. And I hear it will explode. I'm pretty sure next year or a year after. I did some code reviews this year, and clients say, okay, our hope is going to be cheaper. And they already did some calculations like single Kubernetes cluster mid-range costs €2,000 a month, which is... with that, the largest Fargate cluster is €200 a month. And this is the largest, So this is a complete different dimension. And this is what I also wanted. I get you. So you have, sometimes there's no discussion. So you have just to do it. This is also my projects. Some of my clients have said, you have to use, Kubernetes, period. Okay, so there is no discussion. I will use it. But this is like, back then we had to write deployment descriptors with XML files. So, okay, if you pay me for this, I could do this, but not for long.
You gave me a very interesting point to think about it. Actually, what I completely agree with you is that Kubernetes is expensive. It's more expensive to operate. Yeah, that's really true. We definitely have to consider those ideas. Yeah, they really sound interesting because so far we have been quite focused on Kubernetes. And to be honest, in my opinion, Kubernetes with the ability to configure the application once and then run it whether on premise or in the cloud, it has some of this. Or it reminds me of this Java initial stuff, write once, run anywhere, exactly. If you still can remember. And from our experience, actually, this works very well on Kubernetes. We have quite many projects where we have demonstrated that we can deploy exactly the same service or application, and it's not only one microservice or one API. These are some complex solutions that we can deploy this on whatever Kubernetes, whether in Azure or Amazon or Google or on premise, without any change in the code or just minimal changes in the configuration. which is quite nice. But what definitely is true is that Kubernetes is not cheap to operate and to run. Yeah.
And the next problem I see is with Kubernetes, you have two APIs, and this already starts, to be more and more problematic. Usually, you would use Helm charts or something similar, or a templating language which generates, the deployment descriptors for Kubernetes. But you still have the Cloud API as well. And the Cloud API as well is way more convenient and it could be fully automated. So if you would run a larger project on Kubernetes, you need a solution for the let's say AWS or Azure API management. Plus, you still have to maintain the Helm charts, and the Helm charts and the YAMLs. They are huge. If you compare it, to my AWS Fargate or Azure functions, we are talking about 40 lines of JSON, maybe, and they are obvious, the contents. So there's a container image, port number, then your environment, your secrets, and you are done. So I think, and if you have,
they are huge. Yeah. I completely agree, and this is also why we started this conversation. That's why we are moving the API gateway into the Kubernetes and into the REST client. So we are separating those responsibilities so that there is no more need to configure external API gateway for such solutions, for example.
Yeah. Mm-hmm. Yeah, you see, this is where it's going, and I think for you it's a right product strategy, Kubernetes, because it is hard to explain to a non developer what I said, right? If you go to a manager and say we will use proprietary AWS and the proprietary Azure features, they are already thinking in migration projects. But the truth is the source code is the same, and we are just adjusting, minor configuration. And my impression is like AWS was the first, and the others try to copy, the AWS APIs or services. Sorry, not API services. Which is good for us because everything is similar. So if you know the AWS product, you can map it always to the other cloud providers. So this is not like they are completely different. They are similar. They have similar offerings with similar APIs and with similar costs even. And but take a look at the function part, because the serverless part is really this, from my perspective, the future. And I tell you also why it is the future, and because of the billing. What I see the next is in enterprise projects, if you run Kubernetes, we always get, the questions regarding sizing. Do we have one Kubernetes, two, which sizing or whatever? And this is hard to explain, where the money is gone, because to make it right, the Kubernetes cluster has to run on 100% capacity or 90%, and is always a little bit over provisioned. So
right. Always, yeah, and you need this worker node and master nodes and so on, and you pay for all this. Yeah, this is true.
And I have no problem with that, not at all, because I say it is still cheaper to over provision the cluster than to over provision developers, because they will have a pre-major optimization is always more expensive than over provisioned cluster. But I have to explain it in every meeting. And this is no discussion like why and so forth. If you use serverless, you change completely the discussion, because now you pay per API call. Yeah. And now you can now you go to product management and say, look, we called this use case 1 million times, and this is the bill. If you earn some money with this, it's okay. If not, we can deactivate the use case, And now, the product managers are in charge to think, actually, is it worth? Is the margin high enough, to support that? And then, let's say even if one API call calls a €1, but they are earning €2, no one has a problem with it. So everything becomes transparent. And at the end of the month, what we can do, right? We can optimize the cost just by looking at the dollars. We say, okay, this function is very expensive. Let's optimize that. And back then, I always had no esoteric discussion. Java is too bloated, too expensive. It's like, what are you talking about? Where? Give me the numbers. There were never numbers. And the first time in the history, we get the numbers. And if I show this to management with the serverless, it always wins. Because the first time in the history, they have the bill, a very detailed list, what costs what, And this is what they want to have. And if something's too expensive, to come back to the architects, like why we pay so much for, I don't know, for the service. And this can be your traffic, this can be whatever, API calls, so we have to optimize something. And this is complete different, reasonable discussion, right? Because then they will see Java becomes more, is cheaper to run than JavaScript or Python because the calls are shorter. So everything becomes, more transparent. This is why I like the new approach, or I have to spend less time in meetings.
This function approach is actually the serverless approach is really something which is very interesting. Yeah. So you think that Kubernetes doesn't have a bright future in that sense, so that the majority of the development will shift to the proprietary cloud serverless or function environments in the near future because of the cost. Because what really holds true is that there is an order of magnitude difference in the costs.
Yeah, this is the true, and I would say, at least in I spend my time Austria, Germany, Switzerland. So the perception is in these projects we will save money. And if I do and for unknown reasons, no one fires up the calculator, and just does the simple math. If I tell them how expensive it is, the answer is it will explode. So okay, but This is only because you do one-to-one. Whatever you have on premise, you try to run it exactly the same way on the cloud, and this is not the right approach. If we do it differently, I don't think it is ever going to be cheaper than on premise. But you could move faster. You have other advantages. This is good for business, but it's not about saving costs. And the next thing is very, very interesting one, because I would say Kubernetes is a more for legacy applications. I would say something runs all the time. We call it I know there's Knative on functions, but I would say Knative and functions on Kubernetes on premise don't make any sense from my perspective, because you need the hardware anyway. I mean, it only makes sense if you are a huge hardware provider, you have a huge data center, and then you can spread the load more evenly. But this is not the of my clients have. Maybe one client, and the others are smaller data centers. And the smaller the data center, the less interesting is the overhead of. This is some overhead running functions they have. The whole management and stuff. And if you what I wanted to say with the cloud. So Kubernetes, I told you, is legacy. Why legacy? What for me cloud native means is, this is the new wave. What I see is so in every project or a review enterprise project, in one point of time, they have functionality like the business department uploads a file. And this is like multi-part upload. So they always, I see, okay, this is proprietary code in JAX-RS because it's not a part of the standard. So it is uploaded, save some in a folder. So what happens with the folder? Then I look, is it NFS or how it's shared? And then it's and virus scanner involved. And then the file is read again, and that's something, right? In the cloud, such a use case is implemented completely differently. And I had also an discussion with cloud architects, which are just spent the entire time in the clouds, and they told me this is interesting that you're thinking differently, because what they would do is, and this is Azure and AWS, you would upload a file to S3 or Azure File Storage or Blob Storage, right. I think is the name.
Right. Yeah.
And now this service emits an event, file created. Then you would implement a Lambda or Azure function with Java. It will get the event. Here's the file. So, I mean, you can skip already one service which runs all the time, and you get the file. So, and you will pay, for 1 million files a month, nothing. So you have already the file. Then you can decide what to do. So you can get the file or get the reference to the file, the URI, send it to, let's say, SQS, which is a queue. Another Lambda wakes up and does, let's say, a virus scan, or you would use a virus scan service, which is part of the cloud. So this is already done. And then you can pick the file and write it to S3 bucket again, or whatever you like, or that database. But the point is, you have 3 Java methods instead of an entire service, which runs all the time. And you pay a subset of the costs and is way simpler and way more secure. This would, for instance, this is one, and upload an Excel to the cloud or CSV. I see it more and more coming. So the difference is in the cloud native, the future serverless is what for me is event-driven architecture. So the entire cloud emits events. So every service I know, from Git repository to pipeline to load balancers to EC2 machines to Fargates or to Spot instances, everything emits events. And what you just do in the new world, you are listening to events and do something else with it. And we can do it absolutely with Java, but I don't see Kubernetes there. I would say I have no idea what the place of Kubernetes in such architecture would be, because we don't need it, right? And I see more and more such use cases. And if I present the idea there were last week, there were the AirHacks workshops, AirHacks Live workshops again. And they told me, that's right. So we also have such. One guy said, okay, for years we did hundreds of microservices, but this is actually the use case. So we can do it up far more simple. And this thing, for instance, all lambdas are versioned. So versioning, the canary is built in. We don't need load balancers. We don't need nothing. And I would say this is the future. The only thing is, people are believing that Java is not right for that because of the cold start, which maybe happened once, but every subsequent cold get faster and faster because the cloud providers are remembering the Java optimizations. So what we have for such calls, we already are in 2 milliseconds to 6 milliseconds performance, which is great. And we are writing old Pojo style code. So I would say for you could be super interesting as Kumuluz provider, because Lambdas provide also extensions for traffic, for monitoring. So focus a little bit there. And I would say there's a huge hole, but because no one sees how good Java actually is in the serverless and just combine it the right way.
Yeah, I agree. This is very interesting thinking. And the event-driven approach is definitely something that it's coming, and I think there will be more and more focus on this. It is just a different way of thinking, and what would actually interest me would be how to combine or how to define this architecture in the cloud vendor neutral way. And this is probably something that it will take quite a lot of time before this will be defined, but eventually if somebody can provide abstraction layer on top of this, then this could be the winner architecture for the next cloud native generation of applications.
I mean, the abstraction is already there. It's called cloud events. This is already the attempt to standardize the events. But
the events themselves, but not the whole architecture, that you would have a standardized architecture for everything. So for serverless functions, for events, for configuration, and for all the other stuff that you need to do in order to deploy a more complex application.
This is true, but the architecture, this is the funny story is, if you know application servers, it's almost identical. This is what you did for 20 years. This is like what I told you right now is like exploded architecture server. Think about message-driven beans and stateless, and you are there. And for fun, I delivered a talk at a conference called Devlix. It was like, hey, EJB developers, you will love Lambdas or something like this. And what I did, I picked, the old EJB specs and explain Lambda with it because it's almost identical. There's only one difference, but I was actually, and the developer said, "This is right. This is like actually EJBs and Lambda are very, very similar." So I would tell you, from source code perspective, there's almost nothing to do. The entire configuration, I don't think it is worth to standardize that because the cloud providers will be always different. I just announced this opportunity for you just to think about this right now, because if you go to my YouTube channel and look at the recent screencasts on AWS, in 5 minutes I developed such a function on Quarkus, and you will see it's MicroProfile app. There is no difference to Whitefly. And to integrate Kumuluz to that, I would say it will take you a weekend, a proof of concept.
We will definitely have a look at that.
And then we have to talk again.
This is definitely a very interesting topic, so thank you for pointing this out. Yeah. Certainly. And yeah, I also agree with you. I also, for example, when I have some workshops or teach students or something like that, I also often point out that the concepts are repeating themselves. Yeah. So basically, the concepts that we had in the Java EE, the app servers, and so on, they are coming back in a little different form. But these core concepts are really similar.
Yeah. What I'm doing, I'm picking my old Java E concepts. I don't mention them, Java E at all, and everyone thinks I'm smart. But I'm not smart. I'm just trying to remember what I learned 20 years ago. I said, wow, yeah, this is a good idea. I was like, yeah, then don't mention Java E. I say, yeah, it's a cloud native. I say, okay, nice. And this is actually the entire trick. And yeah, and the also interesting part, the idea of event-driven architectures. I get the questions for 10 years at least. So all conferences, all the attempts with Akka or whatever, just to send events back and forth, and I always ignored it completely because I say I'm not crazy. Why I should create my events first and to listen to them? A request response call is always simpler, but in the clouds we have the events already. So this is the huge difference. Every service already emits events, so we don't have to create them. We only have to listen to the events. And this is the major difference. And so my expectation would be that it just explodes in the cloud, but for unknown reasons, as you said, so many developers still, or developers, many companies still expect to run Kubernetes on the cloud and ignore the entire ecosystem, actually.
Yeah, this is often the case, yeah. Yeah, this is often the case, yeah. And it's an interesting development, actually. It's a really interesting development which will have a profound impact on the architecture of the applications, because following the architecture patterns that you have described results in a completely different architecture than following the way you should architect the applications for the Kubernetes.
Yep.
And yeah, the complexity of Kubernetes is larger and the cost of operation is higher. This is definitely true.
And Kubernetes is also not truly serverless because you cannot shut it down to zero. You always pay for the control plane. So you can always ask, so okay, it is, even if it is sold as serverless, you always have to pay for the control plane, which is problematic because even if it costs €100 a month, the problem is you need, truth is, multiple Kubernetes clusters. What we do, for instance, in cloud native development, every developer gets an own account for development. So it would mean every developer will get an own account with Kubernetes. So already we are paying €100 per developer, right? So for nothing,
right.
Which is problematic. Okay, perfect. So it was great with you again. So we didn't cover the API gateway to all, but closing API gateway. What I will get if I would use your API gateway? Is it like a MicroProfile REST client, or what is it now?
Well, currently it is Kubernetes native API gateway, which provides really tight integration with Kubernetes and simplifies the configuration of applications. Which you would like to deploy to the Kubernetes cluster without using some external services of whether a cloud vendor or of an on-premise deployment. And the motivation behind this is to deliver applications that can be deployed in exactly the same way on-premise or to whatever cloud Kubernetes provider you choose.
Okay. Perfect.
And this is where you get something. Yeah. Now, whether you want to go this way or go the serverless and cloud functions way, the way you describe this is another question.
Okay. Now, perfect. Because I was curious to know what would be the next API gateway, because you said you would like to move it to the clients. And then I thought, okay, then it's going to be MicroProfile REST client or something like this.
Well, not exactly. It's just that we move some part of the functionality so that we don't have to route each and every call through the API gateway, but still implement some of the functionalities such as authentication, rate limiting, logging, audit logging, and so on. Even in service-to-service communication, which happens within the application, and you don't have then to route all the calls through the API gateway. So if you have several services on the back end, And this part of the functionality, we are moving to the REST client proxy. So we are basically extending and adding a proxy there in between in the communication in order to optimize the communication between services and to simplify the configuration and to reduce the load on the actual API gateway instance.
So now I got you. So where the listeners can find you on the internet?
Well, there is our website, Kumuluz.com. Yeah, they can email us.
I put all the coordinates to the show notes as always.
Great.
Perfect.
Great. Thank you very much.
Thank you, and hear you and see you next time.
It was a really nice discussion. Thank you very much. Goodbye.